All right, so welcome back, everybody. It is my great pleasure to introduce our next speaker, Luis Amaral. Again, I met Luis many years ago, and he had this incredible breadth in his research, not just in science of science, but recently in the justice system and all kinds of directions. Very extremely creative researcher. Luis is the Erastus Otis Heaven Professor in Chemical and Biological Engineering with appointments in physics and astronomy and medicine in Northwestern University. He conducts and directs research that provides insights into the emergence, evolution, and stability of complex social and biological systems. His research has broad applicability and addresses pressing challenges facing humanity, including mitigation of errors in healthcare settings, the characterization of conditions fostering innovation and creativity, and the growth limits of sustainability. He received the Career Award from the NIH in 2003 and was selected as an early career scientist for by the Howard Hughes Medical Institute, HHMI. He's a fellow of the American Association for the Advancement of Science, the American Physical Society, and the Network Science Society, and the American Institute of Medical and Biological Engineers. Professor Amaral will now present his talk, Some Pandemic Prompted Thoughts on the Current State of the Scientific Enterprise. So please help me in welcoming Luis. Luis.
Hi, it's really my pleasure to be here talking to you. I hope you can hear me without any problems.
Yes, we can hear you. Yeah.
And so, I always think that it's good to tell you a little bit about yourself before you start the talk, because that kind of illustrates what your bias may be. And so, just in preparation for the people that don't know me, I am very opinionated, and that should become very clear through this talk. I have a sense of distrust for authority. I can also get angry with things. And the last one may require explanation. So when I get into a situation, I don't accept the way that it is, but I think, how could it be made different? And so that, if I go to a room and I'm sitting with friends, I will start moving tables around for us to sit together and stuff like that. So that sometimes doesn't make me many friends, but I think it's important to be able to talk and describe things the way that you see it, with honesty. And I hope that you believe that I'm being honest in the things that I'm saying and that I feel strongly about them. So is this a buzzkill talk? Yes, it is. And so, because we are going to get the press through this talk, I always think that it's good to do something that makes you feel good. And so, to me, I love this quote from Axelrod. And he wrote in a book, "To this day, I am delighted that the political scientist was able to adapt a tool from computer science and thereby contribute to evolutionary biology." And this thing just makes me feel all warm inside. Kind of the way that science should be, with knowledge transferring from one person to another, from one field to another, and us kind of together trying to solve problems. And so it's something that makes me feel very good, and it makes me feel good about science. At the same time, there are many things that don't make me feel so good about science. And the pandemic that has been mentioned in here has sort of been a realization of our politicians cannot be trusted, right? I mean, it's like across the world, you saw people fucking things up really badly. There have been millions of people died because politicians were unable to do something so that nothing happened, nothing better that happened. So they prefer to let people die. And you have seen institutions, scientific institutions, that have been behaving in a shameful way. I mean, the CDC has been an example. I mean, the way in which they are making determinations has been completely shameful. And it has been not driven by science at all, or by an acknowledgement of what we do or do not know. But it has been seen in other ways. And one way in which I felt it was as being an editor at +1. So for some of you that may be editors, papers are submitted to journals, and then, you know, in +1, they try to find an editor. And this is an example of a case in which I was the editor that ended up accepting filling the paper. But by the red boxes, you can see that there were a lot of other editors that were contacted, and none of them pick up the paper. Now, this is not too much of a problem because, you know, we are all busy, we all get lots of papers. But this paper has been particularly interesting to me because this was my attempt to find reviewers for this paper. And, you know, I sent lots of invitations for reviewers, and I couldn't get anyone to take the paper. Either they said that they were not experts, even though they had been suggested by someone that said that they were an expert. They didn't reply. They said that they were too busy. In the end, I had to review the paper myself because I was feeling really ashamed to the authors. And so this thinking me about what's going on with science, right? I mean, it's like we are supposed to be reviewing each other's work. Why aren't we able to find people? So what is going on? And I think what's going on is a lot of bad things. I mean, maybe science is not broken, but it's on the way to be broken, I think. And science is not broken in the same way that the climate was not broken in 2000, right? That we say, oh, we can make these goals about stuff, and 20 years later, we haven't done anything. And we are making the same promises now that we made in 2000 or in the 1990s, and nothing has happened. And so I think the same way that the climate was not broken in 1990 if we had taken action, science is not broken right now if we take action. But if we keep telling that things are sort of okay, there are a few dark clouds here and there, the problem is not going to be solved. So, what could be going on? Well, we all hear that it's good to publish. Sorry, there is an alarm going on in here. It's a test alarm, so I will not have to run and hide from a shooter or something like that. This was a comment published in Nature in 2018 by John Ioannidis. And he was talking about the proliferation of hyper-prolific authors. So these were authors that published more than 72 papers a year, so one every 5 days. Now, this is not the worst of it. The guy that was leading the Pasteur Institute, the year that he won the Nobel Prize and he was going around the world giving talks, he was an author in over 300 papers. So more than one a day. So what is this? Can someone contribute to 300 papers a year? If we all are so busy writing papers, are we reviewing any papers? Right? It's sort of publishing became such an idol, a goal, that we are stopping doing the things that matter, you know, like reading other people's papers, reviewing other people's papers, thinking before writing another paper. And so this could be one of the issues. Actually, Ioannidis is a funny guy because he wrote about these hyper-prolific authors, and I was looking at it, and since 2016, he has published at least 900 papers. At least those are the papers that have at least 10 citations. So yeah, it could be that he's also part of the problem. I mean, maybe he doesn't sleep, right? Maybe he can provide feedback on papers very, very quickly. Oh, did I say that I will name names in this talk? If I didn't, I should tell you, I'm going to name names. But everything is great. So during the pandemic, and as things were going crazy, my university sent an email to all of us about how great we were doing. So this is a graph. Last year, 2020, we had almost $900 million in federal funding for research. And you can see from 2013, it had increased from about 550. It's like, great. It doesn't matter that some people are struggling. It doesn't matter that some people are dying. Our funding increased dramatically. Everything is great. There is nothing to worry about. This is a distribution from 2010 of the amount of funding that NIH funded researchers get. So it's a log scale. So 10 to the 7 is $10 million. And you can see that there are a few people that are over that. The peak marked there by the arrow is at about 250K. Okay, so two orders of magnitude. These are some of the people that in 2010 were receiving a lot of money. Barton, Eric, Gerald, Richard, Gregory, James, Lawrence, Lee, and Monica. Isn't it funny that there are 2 Richards and 2 Lawrences before the first Monica appears? But anyway, Monica is not doing too badly. She got almost $23 million in a single year in funding. Ames was getting about double of that. So, you know, it's great. Some people are really doing great. They are getting $50 million a year. And you start thinking about, you know, science should be a field in which no one has overwhelming power over the system, right? So all of our voices can be heard. We can use wisdom of the crowds, kind of collect our joint learning and direct in which way knowledge is moving. But when someone has $50 million in funding and someone else has 100,000, the differential in power is very big. When someone publishes 300 papers and someone else publishes 5, how much you can push the direction of a field is not all the same. And these imbalances in power are something that is making the attempt to discover the truth harder. And it leads to other sort of behavior. So we have Eric Lander here again. And things like, I don't know if you follow this, this was a paper, a perspective that was published in Cell by Eric Lander, who was the director of the Broad Institute, where one of the researchers that was fighting for patents for CRISPR was working. He was clearly not an unbiased observer. The Broad Institute was going to benefit economically, very dramatically from the patents, but he was still able to present his unbiased view of the field and who the heroes of CRISPR were in Cell, right? It's like, this is not right. Or you have people like a famous economist that was president at Harvard and that in a meeting makes statements about women not being good at science. And this was in an article in the Guardian a bunch of years ago. And I like to show some stuff from it. So Richard Freeman was the organizer, And I mean, he seems to be a wonderful human being. I love this stuff that he says. Said Dr. Summers' comments were intended to provoke debate, and some women overreacted. It gets better. Some people took offense because they were very sensitive, right? It's kind of, yeah, women, they overreact, they are very sensitive. Naturally, they are not well suited for science, right? We are just being objective here. We are not denigrating a group of individuals and making them feel unwelcome in the field. And of course, this is no implication on the real world, right? Because they are just thinking through things. Interestingly, during his presidents, the number of tenured jobs offered to women had fallen from 36% to 13%. And only 4 of 32 tenured jobs openings were offered to women. Coincidence? I'm sure, because I'm sure that Larry Summers has no bias towards women, just like James Watson was not a misogynist or a racist. It's all good people. The Chronic of Higher Education had this sort of news about the way in which the pandemic had overburdened women scientists because of schools being closed and all of that stuff. And Jessica Calarco, a sociologist at Indiana University, made this great quote: "Most countries have safety nets, the United States has women." Yeah, when there is extra work to throw, you know where to throw it. But you know, the system is all going great. Okay. Let's look at this quote again, because I think I'm depressing everyone. So it's good to think about the positive sides of science, the search for knowledge, the collaboration, the transfer of information, and all of that stuff. And to take a deep breath and a drink of water. Okay. So another thing that worries me is what I see as the House MD view of science. So I don't know how many of you ever saw this show, House MD. So House was a complete asshole, right? But he rode a motorcycle and he wore leather jackets and he was a genius. So he could get away with pretty much everything. And it's kind of, he was the one always solving the problem. Doesn't matter how complex it was, in the end, he found the solution. And there is this view that we want of magical advances by extraordinary individuals. Okay, and let me give you an example. So this is a curve about the increase in life expectancy from birth in the United Kingdom from 1765 to 2020. Okay, and it goes from something around 35 to over 80. You know, and this period, 1765 to early 1900s, was when medical schools were being formalized and established around the world. And you can think about, wow, medicine, this is amazing. Medicine really transformed our life. But then you start seeing about certain things. And you think about, yeah, right, miracle drugs, miracle ways to examine people. But you start looking at the data and you see that there were some changes. So for instance, in the 1900s in the US, the top causes of death were influenza, pneumonia, tuberculosis, gastrointestinal infections. Only then came heart disease and cerebrovascular disease. In the 50s, you know, all of those infectious diseases have disappeared from the list. The same in 2010. And actually, there is something very interesting. This is data for the US on a shorter period, and it's showing the life expectancy at birth in green and the life expectancy at 10. Okay. And this is the interesting thing. Life expectancy at 10 has not increased as dramatically as life expectancy at birth, because kids, young infants, used to die a lot. They used to die a lot from childbirth. They used to die a lot from hunger. They used to die a lot from infectious diseases. And so a lot of those improvements have been due to things as simple as having a theory of germs, the development of sanitation systems around the world in urban areas, right? You started having sewers and running water. And then antibiotics, right? So vaccines, kind of urban infrastructure like collection of garbage and sewers, and then antibiotics. Three things that actually saved a lot of lives. It's interesting that these three things are essentially a huge problem right now in science. People are not trusting vaccines and making a topic of discussion. We are not spending money in infrastructure, so sewer systems and clean water systems are coming to a breakdown point, and antibiotics are kind of hitting a wall in which we are not really developing enough novel antibiotics to solve new infections. But what do we worry about, and where do we put money in medicine? On CRISPR, to genetically solve some disease that has almost no impact in terms of public health. There are simple things that we can do that have huge impact, but we keep obsessed with these miracle things. And the same thing has been going on with the pandemic. You know, masks, they work beautifully. For the longest time, there was all this controversy and back and forth messages. You know, racism, you know, people in Asia were using masks, but in the US, we thought that we knew better, right? That we didn't need to use masks, that they didn't know what we were doing, right? We were looking for miracle cures like hydroxychloroquine, where people could be making money. So it's this obsession of not using things that we know that work, but kind of looking for the next new shiny thing that some genius is going to invent. Bruno Lemaitre had this really great commentary in the FABS journal, Science, Narcissism, and the Quest for Visibility. And it really describes a lot of the things that I find very worrisome with science right now. And I recommend to people to read it. Yeah, this guy. So to give you an example from my own research, there has always been this big conversation about how women publish less than men. And this is put in terms of, this is a deficiency from women researchers showing that they are less suited to scientific careers than men, right? So we actually looked at publication rates by discipline. And we looked across 7 disciplines from industrial engineering to molecular biology. And we looked at the differential in publication rate measured by the average score of women versus males. And we plotted against the research requirements in millions of dollars per PI per year. So this is a log scale. And what it tells us is that in industrial engineering, at the top departments, a faculty member has about 100K in resources for their lab. And in molecular biology, the resources are about 2 million. And what you see is that as the resources increase, the differential increases too. Could it be that women are given less resources, as it was shown in the study at MIT, that they were given smaller startup package, less lab space, and that's why they are not able to publish as much, right? What is the cause and what is the effect? And if you don't go and look at things in detail and try to see what's going on, you may miss an understanding of what's going on. To people like Summers, the only thing that matters is this aggregate thing without context, in which women publish less than men, and so they cannot be as great as scientists. So, what is science? I did the thing that many people do, which is go to Google and start "science is," and apparently science is magic that works. And science is the belief in the ignorance of experts. So cool. I learned something. I had no idea that these were the things that were going to come out. But what's science to me, and now we think about it? Well, science is supposed to self-correct, right? It's supposed to kind of try to replicate studies, findings, and see, are they for real or not? Science, like a coral reef, builds upon itself, right? It's supposed to continue to take new knowledge and integrate it. Science is using critical thinking skills in evaluating what's going on. And it's about reproducibility and replicability, about the ability to be able to do all of these things. But is this what we are doing? Are we really doing this? Are we trying to self-correct? Or are we afraid to publish something that goes against what someone famous wrote? Are we thinking about what's the right problem to study? Or are we studying the problem that the Nobel Prize winner set in his last paper? And it's his last paper because women get so few Nobel Prizes. I'm sure there is no bias in that either. The quest to publish fast and a lot is leading to things that I call, combinatorial publishing. This was part of a talk that I gave many years ago about the study of complex networks. And it's sort of complex networks is a hammer. So you have all these nails on which you can apply it. And people were just using complex networks in fractals, percolationizing model, random walk, spin glasses, and kind of just turn the crank over and over again. But there is even worse. There is the Lemming publishing, right? The yet another small world or scale-free network model in which you make a tiny little change to the model and publish the paper. And it's kind of, I gave a talk. When I gave the talk, someone came at the end and told me, my first paper was a modification of the Barabasi-Albert model. Is that not appropriate? And I said, and he asked, and I said, no, that is something that an undergraduate can do in a homework set in the networks class that I teach. But he said, then what I'm going to publish? And it's kind of, read the freaking literature, find out what is an important problem, right? This is like, oh, but this is an easy way to get a paper, so I should do it. No, you should not do that. The other thing that is going on that drives me crazy is the sort of jumping in the bandwagon with the shiny new gadget. And I could talk for like 5 hours about this. Actually, no, I could talk for 5 days and get increasingly upset as I did. It's sort of, there are microarrays, for instance, in molecular biology. Microarrays is exciting. Then Microarrays are crap. You cannot trust microarrays. RNA-seq is the thing to do. Let's all move to RNA-seq. Oh, wait, now we can do single cell. Let's all do RNA-seq of single cell. And you are in NIH study panels, and if someone proposes to use microarrays, it's sort of, why are you using these instead of the other thing? And it's kind of, you have to use the new little gadget. And why is this a problem? The reason is very simple, in my view, is that these technologies are the equivalent of a rocket to send someone to the moon. And let me explain what I mean. If you want to buy a car, you can go to pretty much any car salesman and buy a car, right? And you know how it works, right? You know, turn the engine on, you have the driving wheel, gas, and brake. You know what it's supposed to do. When you buy a rocket ship, you cannot go to a store, right? It's not like you can choose from 100 models of rocket ship to use. When you are building a rocket ship, you have to figure out and understand every of the components because nothing is sort of standardized and well known. Think about single cell RNA-seq. The experimental process as this very large pipeline using algorithms that have not been properly validated, that are used in some combinatorial fashion by people that have no understanding of how their parameters work, and then publish results based on the assumption that whatever I did, the result is going to be the same. Sort of, if I press the gas pedal on a car, my car is going to accelerate. You know, does a rocket ship even have a gas pedal? Do the gas pedal and all of them work the same way? Right? And people are not aware of that complexity, but they are jumping into the shiny new gadget without understanding it. This is an analysis that we did of microarray chips. And essentially, the things that you see there in dark colors in the rightmost panel are indicators that the chip was damaged. Okay, so this chip had huge damages throughout it. The authors published the study and their data without realizing that their chip was damaged. Essentially, they were assuming that everything was going to work just fine. Artificial intelligence and machine learning are the new magical ones that have no limits to what you can do. You know, this very, very nice study was just recently published in Nature Machine Intelligence. And it's essentially showing that all of these machine learning algorithms to detect and prognosticate COVID-19 using chest radiographs and CT scans were actually focusing on the fonts with text and which hospital the X-ray had come from. You know, it's sort of, you use this magic thing, you don't try to understand why it works. And then you something that works beautifully in your training data. But when you go out of sample, it would fail because it would be from a different hospital and a different machine with different fonts. So why am I saying all of this? Because I think it's important for us to realize that we are facing a serious situation in science, and it's upon each one of us to make the right choices. If we act like sheep, following the leaders, science will be broken. You have to ask yourself, which research problems are you choosing to tackle? Are you going to make another little modification in a scale-free model because that gives you a paper, or are you going to address something that is really important? Will your research be about the people that win Nobel Prizes? Or is your research going to be about the bias and the systems that exclude researchers from science? Is it going to be about how do we create conditions for people in the developing world to be able to do good research? Will you be doing research that is reproducible, that is serious, or are you just going to try to publish and get away with as least as possible? And finally, and more important, are you going to be an independent, critical voice of what's going on, or you're just going to accept that the tables are set and the people at the table already have their seats and they can continue to do as they want? You are starting your research career, and if you do not make the right choices, I assure you that research is going to be broken, just like the climate is getting broken. So no biggie. It's all good. Thank you.
Thank you, Luis. Really, really powerful words and message. I just love, love this stuff, and we need more of these critical voices. So if there are questions from the audience, please raise your hand. Okay, so everybody's like completely okay. So here we are. So what, Nick, go ahead. Okay, what about Rodri?
Hi, thanks very much for the talk. Loved it. I was just wondering if you had kind of any more recommendations on readings about kind of examples of shiny gadget science gone wrong. Partly, I'm looking at an area at the moment, which is intranasal oxytocin field. Oh, I can't see that. It's gone blurry.
It's artificial intelligence, a guide for thinking humans. So one of the things that I think is extremely important is for people to learn about the history of science and of knowledge, because that provides you a huge amount of perspective. It's like the same kinds of things went on and on, and the same kind of struggles. When you learn about past scientific developments, you learn it in a kind of sterile way. Everything worked. The guy came up with this discovery and all made sense. There is another book that I love called Inventing Temperature, and it talks about the multi-century process to come up with a deep understanding of what temperature is. It's like none of this stuff is easy. None of it is going to be easy for us. We all have to struggle. And the problem is when people believe more in being right than in kind of searching for the truth. So my recommendation is history of science. There are lots of cool things to learn about what happened and how petty people were. It's like you have this, there is a discussion between Herbert Simon and Benoit Mandelbrot about multiplicative growth. And it's like, those guys were really humans. and that is the thing. These people are humans, they are not gods. And so you should use your critical mind.
Thank you. I agree very strongly with the history and sociology of science comment as a historian and sociologist. So thank you.
Nick, go next, please.
Hey, thanks so much. I'm curious what you think about kind of the filtering and selection mechanisms in academia. I think a lot of the pressure that non-tenured or postdoc people feel is, not to shake the boat, to stay in the realm. And I wonder what you think about that.
So I'll tell you something personal. My father has a 4th grade education and my mother has a 3rd grade education. Okay. I'm an academic professor. So at some point you have to stop giving a fuck about it, right? It's sort of just realize how lucky you are. If you are afraid of stepping on any toes, you are not going to be advancing the field. You are going to be enabling some people that may be actually very dishonest to maintain control over things. It's not easy, but I think that we actually all have to be, I think people will be happier if they leave a field thinking, you know, I tried to modify it, they excluded me. You know, there are other careers. People in science are very smart, they are very driven, they can be successful in many different areas. I think at some point you have to be able to say, you know, I'm done with this. Because if you don't, you know, it's kind of, the system is not going to improve, right? That's how corrupt systems are maintained, because people think, oh, I don't want to endanger myself. You know, I heard a story about why Carl Sagan was not elected a member of the National Academy of Sciences, because a bunch of these people were jealous of him and kind of the statements that he made. He probably knew, right, that he could have just said things a little different and he would not have pissed off some of the people. There are things that you are not going to be getting, but we all have to work to make the system better. I'm not recommending that you go burn so many bridges that you have to live under a bridge, but I don't know, I'm sorry. I'm probably not making very much sense. It's very easy for me to say stop also from where I'm sitting. You are muted.
Oh, I'm gonna go with Luis Dano. Sorry, I'm saying that I would like to diversify a little bit. Who is asking questions?
Hi, Luis. Thanks for the talk. Really nice. And my question is, can we fix science without fixing society? Because I think that the problems that we see in science are the problems in society, right? This like ultra-capitalistic view of everything. I mean, that we want for benefit, we want to publish more, to have more funding. We go to the new toys because in the end, your application for funding goes to a politician that does know shit about science, and you have to make it sound fancy. So you put things like artificial intelligence, machine learning, and so on. So I don't know, how can we fix all these things without fixing the whole model, right, of economic production?
I couldn't agree more with you, and this is the big issue, and it's like, oh, scientists have to be impartial and not advocate in one way or another. How can you not be advocating on things that you are more informed than others, right? And it's, I'm in a chemical engineering department. Okay, at some point we had the kind of president of our association, the American Institute of Chemical Engineers, come and give a talk. And he was talking about the risks due to fossil fuels and climate change, and he encouraged us to try to publish op-eds. And I raised my hand and I said, wouldn't it be much more effective if the institute that represents all chemical engineers would write the op-ed, right? This is the opinion of our collective thing. It's kind of, we need to pressure our societies, I mean, scientific societies, to take stands on things. And on the scientific side too, it's kind of issues that are going on in the world affect the way that science is done, affect the way in which choices are made. You know, the scientists at Oxford that developed one of the vaccines, they wanted to make it free with no patent, but they were pressured into patenting it and then licensing it. You know, and now we are going to be seeing tens of millions of people dying in the developing world because some people have to make some more money. I mean, this is disgusting. This is beyond, and you know, yes, individual scientists can scream and shout about it, but our societies have much more power than us individually. And it's astonishing that we cannot get them to collectively talk about this. You know, it's like the American Physical Society, the American Institute of Chemical Engineers, you know, all of the Society for Microbiology, all of them should feel this is something that we need to talk about. Right? It's not. It's like, oh, I'm a student. I shouldn't be talking about these things. Or, you know, I want to win a prize from that society, so I'm not going to be pressuring them about this or that. But we need to start doing it. You know, my administration, who used to love me, now hates me because I created a lot of stink during this past year about all the shit that they did. You know, it's like, yeah.
So we have a question from Sylvia. She couldn't raise her hands, but she asked the question some time ago. And then I'm going to go with Ying and then with Robert. Sylvia.
Thank you. So actually, it's a good timing because it's kind of a follow-up question about this. Can we fix science without fixing society? And you were saying like, yeah, the opinion of the collective, we have to do it. And I love it. I wish, I don't know, what should we do? Is it something like academics of the world unite and create unions? You know, but where are they? Like, because I'm sure this feeling you have, it's already out there in the world, right? As you said, like there are many people thinking about this, but I only know, for instance, the example of the Netherlands, that they were against paywall and they were like, okay, if this was funded with public money, it cannot be published behind a paywall. And it was a collective stand, but I want to know more examples. I want to know who is, you know, like really doing something about it, because as you said, you are in a position of somewhat power, right? You have a job and stuff like that, and I would like to have one as well eventually, right? But there's like all these stuff of publishing and so on. So I know, you know, I know in the Industrial Revolution, people had to leave their jobs, right? Maybe that's your call. Maybe I should do that. Maybe I should be without a pay. But I would love to know if there's already, you know, a collective out there. What should we do?
I think the first thing is for us to talk more about this stuff, and to encourage and support the people that are doing. So at Northwestern, which is a quite wealthy university with lots of wealthy students too, there have been a lot of rallies and movements by students to support kind of service employees, you know, janitorial staff, dining room stuff and things, and also to protest against police violence. And actually, the students were beaten up by the police in a manifestation. And I have gone to some of those rallies to support the students, but at the same time, I think this is about them taking a stand. And I think the role some of the older people is to be supporters of the young ones, because there's the young ones is where you may have a majority of people that are thinking about the change. You know, I find it very frustrating that my university has made a bunch of decisions that were really bad, and the Department of Political Science was able to put a statement criticizing the university. I tried to get my department to do the same, and essentially there was one vote against the rest, right? It's sort of, but amongst our students, the excitement about it was much, much greater. And many of our students were actually involved in all of these activities and protests and all of this stuff. So it's, yes, you have to change your focus. But I think you change your focus and you change your expertise to reveal what is wrong. And also to be vocal about it. And it's costly. It is really costly. I'm not saying that it's not. And I don't know. I'm just hoping that, you know, more and more people, you know, it's graduate students in Columbia University went on strike, right, for better rights. And they were being accused of this, of that. They were threatened that their tuition and their stipend would be taken back and all of these things, but they took the chance to fight for something. And the thing is that when people unite and fight, they can win. It's not guaranteed, but they can. And if they don't, you are kind of accepting less and less.
Yeah, but that's why I was asking if there's like a call of academics of the world unite, because, you know, that's what, it's not just Columbia University students, Northwestern University students. I'm guessing this is like something happening all over the world. So I was hoping, and there's the Ich bin Hanna movement in Germany and so on. So I was just hoping, is there an open call? Is there an open movement?
I think a lot of the thing you have to start organizing locally. Right? You have to create something, and then it's sort of a network of networks of networks, right? You try to connect with other people. And I think academics have an advantage in that, because we have our local networks, but because of scientific conference and all of that, we get in touch with people from other areas. So actually, if there is an activity going on in one area, that may connect to another university and another country. But indeed, we need to start organizing, and we start organizing, which is really hard, with people from less fortunate countries than us that are struggling with much harder. But okay, I mean, so we probably should go to the panel.
Yeah, sorry. Let's save all that energy, and thank you for this powerful talk, Luis. So I know that there are people with questions, but let's save that energy for the panel. I'm gonna